Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at further integration, where we are going to be solving equation on reduction formulae. So the question says you have an integral defined in terms of two integers m and n. So I of m comma n is equal to the integral of x to the m times the ln of x to the n with respect to x, and we have to prove this relationship. So basically in situations like this we always pass through integration by parts. Now since we are asked to prove something, in integration by parts we always let one quantity to be u and another quantity to be dv. And when we let one quantity to be u, we differentiate that quantity, and you clearly see that in this proof, right, the subscript n has decreased by 1. It means that we have actually differentiated ln x to the power n, because it is only when you differentiate ln x to the n that you're going to get a power here as n minus 1. So that guides us to letting what our u and what our dv to be. So we are going to say our u is equal to ln x raised to the power n, and then we differentiate both sides, okay, with respect to x. So du is equal to, how do I differentiate ln x to the n? I drop the power, I differentiate ln x, and then I multiply it with ln x to the power n minus 1. So I'm differentiating with respect to x. So if I want to rewrite it, I'm going to rewrite it as n divided by x times this, okay. Now the remaining quantity, I have dv equal to x to the power m dx. That's the remaining part of the integral. So to get v, I need to integrate both sides. So integrating both sides, I get v to give me m. When we integrate x to the m, we have x to the m plus 1, right, divided by m plus 1. Okay, so my integral, we just use a formula. It says the integral is equal to uv minus the integral of v du. So this integral is equal to uv minus the integral of v du. So we just need to fit in. Our u is ln x to the n, okay. Our v is all of this, so I just need to multiply this with x to the power m plus 1. Then I divide this product by m plus 1. Then minus the integral of v du. Minus the integral of v du. My v, you have x to the m plus 1. X to the m plus 1 divided by m plus 1. And my du is n divided by x times the ln of x times the ln of x raised to the power n minus 1. Okay, so let us simplify. So this is going to give us, remember that it is im comma n, which is equal to this. So it's better we write it down. So this means that im comma n is equal to, now here I'm going to factorize in this integral, right? In this integral, let me explain what I'm saying. Now in this integral, m plus 1 is a constant, n is also a constant, so I'm going to write this as n divided by m plus 1 out of the integral. Now x to the power m plus 1 is the same as x to the power m times x, right, times x. Now you see that there is a divided by x here in the denominator, and you're multiplying everything with ln x to the power n minus 1. That was just simplified. So this means that if we want to simplify, you realize that this quantity cancels, okay, and then we just have this. Now you realize that this integral here is simply im comma n minus 1. So we now, maybe we can multiply all through by m plus 1, okay, we can multiply all through by m plus 1, and we are going to get that m plus 1 times im comma n is equal to, I'm just going to be left with this numerator. Okay, I'm going to be left with this numerator minus, I'm going to be left with n. Now this integral here, you realize that that integral is simply I of m comma n minus 1. Oh sorry, I of m n minus 1. Okay, so that is it, because you see that x to the m remains. If you check the original integral, this is x to the m. You see that here we have the subscript n and we have the power n. So if the power is n minus 1, it means that the subscript is supposed to be n minus 1 as well. So this is what we had to prove. We had to show this. Okay, so we have successfully shown it, so we can conclude as required. Okay, so thank you guys for watching. Make sure you subscribe to the channel, turn on your notifications so that when I upload the next videos on reduction formula, you'll be notified to come and watch. Do well to comment about the video in the comment section, like the video and share the video with your friends. Okay, stay blessed and see you in the next video.